Okay, this is practice problem number 3 from section 12.5, the first half. And this is about finding the equation for a plane that contains these 3 points. 1, 2, -3, 0, 1, -2, and 1, 2, -2. I'm going to label them A, B, and C just so we can work with them a little bit easier. Okay, finding a plane that contains 3 points requires that we find 2 things. It's the same 2 things we need anytime we want the equation for a plane. We need to find the normal to the plane, and we need a point in the plane. Clearly, we have 3 points in the plane here. And to find the normal, we just need to take the cross product of 2 vectors that lie in the plane. Remember, the normal isn't any particular vector. All we need from it is its direction numbers, so any normal will do. In this case, we'll find the normal by crossing the vectors a, b, and b, c. So first, the vector a, b. That's going to be 0 minus 1, 1 minus 2, and a -2 minus 3, or -2 minus a -3, and that's -2 plus 3. So AB would be -1, -1, 1. And then I'll find BC as my second vector. BC will be equal to 1 minus 0, 2 minus 1, and -2 minus a -2, which is 0. So there's A, B, and BC, and if I take their cross product, that will be a vector perpendicular to both. That will be the normal. So the normal vector will be equal to AB crossed with BC, and of course that will be equal to I, J, K. I'll build my little 3 by 3 matrix. The first vector, -1, -1, 1, and the second vector, 1, 1, 0. And I need to take the determinant of that matrix, and that will give me the 3 components. So in the I-hat direction, it will be 0 minus 1, or -1. In the j-hat direction, remember that one will be negative, so I'll add the extra negative. It will be 0 minus 1, so again, that's -1, but the negative makes it +1. And finally, the k-hat direction, it will be -1 plus 1, which is 0. So there it is, -1, 1, 0 will be a vector that is perpendicular to both A, B, and BC, therefore it's perpendicular to the plane, therefore it can act as the normal to the plane. And now we can write the equation. So a plane has AX plus BY plus CZ equals D as its standard form, and of course the direction numbers A, B, and C are given by the normal vector. And then I can choose any point that lies on the line. So I'll just go ahead and use point A. So the direction number, -1, times the x component, 1, plus the direction number 1 times the y coordinate, and that's 2, plus 0 times -3. And that's going to give me my constant, and that's going to be -1 plus 2 equals the constant D. So D is going to equal 1. So now I have the full equation. The equation is going to be -x plus y equals 1. And that's the equation for the plane that contains these 3 points.